Hello everybody. Today we are going to discuss the Woodward fischer rules for enones. First of all, we will see what is meant by enones. Enones are the compounds in which carbon-carbon double bond is conjugation with C double bond O. Definition of enone is carbon-carbon double bond, that is alkene is conjugation with a C double bond O. When this linkage is present in our given compound, the compound is known as a enone. General representation for enone is, for example, that is C double bond C, okay, C double bond O, okay. This linkage is present in our compound, at that time we can call it as enones, okay. Last time we have discussed about Woodward's fischer rules for dienes. Again I will repeat this. Last time we have discussed about dienes. What is diene? That is, for example, this 1,3-butadiene. The difference between diene and enone is that in diene there are two double bonds in a diene system, but in the enones there are also two double bonds, but one bond is carbonyl bond which is conjugation with a C double bond C, that is olefinic linkage. Now before starting the problems, we have to discuss about Woodward's fischer rules for enones. Let us consider here. For parent alkane compound. Suppose when the compound is acyclic 6-membered enone, at that time the parent basic value for this is 215 nanometer. Second, if the compound is a 5-member, enone, it possesses basic value as 202 nanometer. Third, if the compound is a aldehyde one, that is presence of CHO linkage in the compound, at that time it can have the value that is equal to 207. Okay, and if the compound is possessed, that is of acids or esters, acids for functional group, what is functional group? That is COH. Esters for what is functional group? COOR. It can possess the value that is equal to 197 nanometer. Again I will repeat this. For parent enone, when the given compound ring is of acyclic 6-membered enone, at that time it have value 215 nanometer. For 5-membered enone, 202 nanometer. For aldehyde, it can have the value 207, and for acids or esters, it can possess value 197. Just we have to consider here one by one examples. See here, for acyclic 6-membered ring, suppose this is a ring. This linkage is present in our compound, it is called as 6-membered. Okay, acyclic means that is C double bond C, C double bond O. This type of linkage it is called as acyclic link. Now consider the 5-membered enone. Already we know the 5-membered ring. Okay, like this. Here suppose this is 5 member ring. This is the keto group which is in conjugation with C double bond C. This linkage is present at that time, you can have the value 202. Aldehyde, when the aldehyde is present at the corner position or at the terminal position, it can have the value 207. If the compound possesses acid or ester, it can have the 197 value. Okay, that is RCOH. Okay, RCOR dash. Likewise that. Okay, with the linkage as the C double bond C, which is in conjugation with COOR. This type of linkage must be present in ester or acids. Okay. Now the number of increments which are attached to the alpha, beta, gamma and delta positions. Rules for increment, addition to enone. First of all, we can write the enone structure as C double bond C, C double bond O. Suppose this carbon atom is in conjugation with this carbonyl group. That system is known as enone. But in enone, we have to number the carbon atoms. Likewise, there is carbon atom which is adjacent to carbonyl group. That carbon atom is called as alpha carbon atom. The carbon atom which is adjacent to alpha carbon atom, that carbon atom is called as beta carbon atom. And if the carbon atom lies adjacent to beta carbon atom, that carbon atom is called as gamma carbon atom. And so on. That is alpha, beta, gamma, delta, epsilon, mu. Up to this, we have to number the carbon atoms in the enone ring system. Now we will discuss the number of increments addition to enone up to only alpha, beta and gamma. Whatever may be, if the structure occurs delta, epsilon and mu value, at that time we have to add the value as a 18 for only alkyl groups, and number of groups we can here list it one by one. See here, first is alkyl group. Alkyl group position alpha, beta and gamma. That is, if alkyl group in the enone system is attached to alpha position, you have to add 10 nanometer. Okay. If addition to beta position, you have to add 12 nanometer, and if the attachment of a alkyl group at gamma carbon atom, we have to add 18 nanometer. Okay. Now OR at alpha 30, 35. Okay. Then 37 and 70 delta positions. Okay. Then OH 35, 30 and so on. Then also there are number of groups which are SH, it is at position 80. Double bond extension, double bond extension. If the conjugation in a enone system is extended twice, at that time you have to add each time addition of a 30 nanometer. If the double bonds present in only one benzene rings, at the time two double bonds are there, at that time this diene is also called as homoannular diene. Homoannular diene. And if the compound possesses enone along with this homoannular diene, at that time you have to add value 39 nanometer. Okay. Last but most important point is that is the addition of a exocyclic double bond. Exocyclic double bond. If the ring contains exocyclic double bond. Last time we have discussed this exocyclic double bond. Again, I will repeat this. That is, suppose this is a benzene ring. Our benzene rings have how many corners? 6 corners. And if any of the corner contains a double bond, then each double bond carries how much value? 5 nanometer. Therefore, if the exocyclic double bond attached to with respect to benzene ring first, are 2, therefore you have to add 5 into 2 nanometer. That is, each exocyclic double bond you have to add 5 nanometer. In this way, you can add the number of increments which are attached to alpha, beta, gamma and delta position. Generally, there is an attachment at the alpha, beta and gamma. Sometimes there are more rare problems due to which in the exams they have asked for that purpose you have to take the delta and epsilon position. Now let us start the problem one by one so you have to understand it very well. I can write here one by one problems, at a time 2 problems, and then I will solve it. First problem. Second problem. This is the structure. Now, this is the first problem. First, we have to identify the given compound is a diene or enone. Generally, this compound contains the carbonyl group. We have clearly understood that this is a enone. After understanding this enone, you have to specify the carbon numbers as alpha carbon atoms and beta carbon atoms. Before this, you have to identify the parent basic value. Which value? Parent basic value for acyclic enone. This is a acyclic enone. What is the parent basic value? According to our chart, that is equal to 215 nanometer. Okay. Now, you have to specify the number of carbon atoms adjacent to carbonyl group. This is the CO group. This is the adjacent group, that is C. This is called as alpha. This is called as a beta. Once you have to specify the carbon atoms as alpha and beta, you have to concentrate on the number of ring residue or alkyl groups are attached to that particular position. Okay. Now, how many alkyl groups are attached to alpha position? This is one alkyl group. How many alkyl groups are attached to beta position? That is one alkyl group. Therefore, here we can write it separately because we have to specify the position of carbon atoms in a enone, not in a diene. Okay, that is for alpha position, for alpha carbon atom, ring residue or alkyl group. Alkyl group equal to 1, therefore is equal to, at 1 alpha position, what is the value? That is equal to 10 nanometer. And for beta position, what is the value? According to chart, for beta position, 1 alkyl group, what is the value? That is equal to 12 nanometer. Any of the remaining here, that is here, double bond extension, no. Molar, no, because it is acyclic, therefore we can take a total. That is lambda max value for this acyclic enone will be, you have to specify these numbers one by one in vertical position. That is equal to 215 plus 10 plus 12, that is equal to 237 nanometer. The lambda max is equal to 237 nanometer. Okay, this is the correct answer and correct position of the writing of calculation of a enone according to Woodward's fischer rules. Now, come to a second problem. In this second problem, what is the structure? Here, this is the structure of an enone. Just you have to identify the CO bond. Okay, that is carbonyl group. Then you have to identify which ring, that is 6-membered ring. Also, the parent basic value For 6-membered ring, what is the value? That is equal to 215 nanometer. Okay. Now come to our first rule. What is? You have to specify the carbon atoms as alpha and beta. Suppose this is a alpha position and this is a beta position. That is, this double bond is in conjugation with CO1. Okay. Therefore, this is alpha, this is beta. You can have the alkyl groups or alkyl residues at alpha and beta position. Alpha position is equal to 1, beta position is equal to 1. Just you have to roll this structure as before writing that is, this is a enone, and this is also a, in a first problem, this is also a enone, in order to specify the enone structure. Okay. Now alpha position, at alpha position one alkyl group, and at beta position one alkyl group. Okay. Therefore, we can add related to above problem, that is equal for alpha you have to 10, for beta you have to 12 nanometer. And what is the total? It is the same answer will become. What is the answer? That is 237 nanometer. All of you understand here clearly? But one care should be taken that whatever may be the structures are different, the values of answers of lambda max are equal to the same. This case happens in any one of the time. Let us consider the another problem. Next problem, I will write here as third problem, that is OH C double bond O, and fourth problem will be as Sierra. Now these are the problems are so many, very simple problems. Just you have to understand the increments and you have to understand the parent enone. Now consider in the system, this is how much member system? That is 5-member system, and from this, which is the carbon atom? That is this carbon. You have to numbering from carbon atom as from here. Here numbering as alpha, here numbering as a beta. Therefore, this system you have to consider as a enone system. Okay. Therefore, parent basic value for 5-member ring what is the value? Parent basic value, that is equal to 202 nanometer according to our chart. Now just concentrate on the alpha carbon atom and beta carbon atom. This is the alpha carbon atom, this is the alpha carbon atom, this is the beta carbon atom. Alpha carbon atom, which function group is attached? That is OH function group is attached. That is at alpha position OH group equal to 1, and for OH group according to our rules you have to add 35 nanometer. How many values? 35 nanometer. Now consider the beta position. Here only one alkyl group is there. This at beta position one alkyl group is equal to, you have to add 12 nanometer. Okay. Now what is the remaining? Anyone know. Therefore we have to take the lambda max by taking the sum, that is equal to 5 plus 4 is equal to 9 to 49 nanometers. Okay. Got it? Okay. Now we will consider this problem. This problem is so much simple. But while calculating and numbering the carbon atoms, you have sometimes is in the mind of a have to consider here as what is the membered ring? That is, it is a 6-membered ring, and for this 6-membered ring, you have to identify CO group from that position also or from that position also. Here we have to consider this position. This is called as alpha. This is called as beta. Therefore, this position you have to consider as a anode. It's a 6-membered ring. Okay, and from the 6-membered ring, parent basic value for 6-membered ring equal to 215 nanometer. Okay, that is for enones. For alpha position or beta position. Alpha position, what is the alkyl groups are attached in this alpha position? No. But beta position, how many alkyl groups? This is one alkyl group, this is second alkyl group. That is at beta position, two alkyl groups. For one alkyl group, what is the value? That is 12. And for two alkyl groups, what is the value? That is equal to 2 into 12. That is equal to 24 nanometer. Okay. Now, here one must thing you have to add, that is the exocyclic double bond. Before adding this, you have to suppose this is as ring first, this is as ring second. With respect to first ring, respect to second, what is the number of exocyclic double bonds? No. But with respect to second ring, these are the corners 1, 2, 3, 4, 5, 6, and this is the exocyclic double bond. That is one exocyclic dB with respect to second ring. Therefore, you have to add 5 nanometer. Okay, here how many values you have to add? That is the 5 nanometer. Whatever may be the remaining, no one should be remaining. Therefore, you have to take the value as lambda max by taking the sum. What is the sum? That is, here I am taking the sum. That is 214, 15 plus 29 is equal to 1, 2, 3, 4. That is 244 nanometer. The lambda max equal to 244 nanometer. Okay. All of you understand it is very well. If there are problems, please ask to me. Again, we will consider the last two problems. Here. This is the most important problem. You have to mark here. That is the most important one. Fifth problem. And last problem, sixth problem is that is here. Now we consider these two last problems. Okay, we have to consider here C double bond O as a enone. As this is an enone, it is a 6-membered ring. Likewise, all other problems we have to write here. Parent basic value for 6-membered ring, that is equal to 250 nanometer. Okay, you have to just specify the alpha carbon atom, beta carbon atom, alpha, beta, gamma, and your delta. Okay, at alpha position, which is a substance? This is. At delta position, which is a substance? Here this is. Therefore, at alpha position, one alkyl group, therefore add 10 nanometer. At delta position, one alkyl group, therefore add 18 nanometer. Okay, now you have to consider the enone up to this system. Okay, already we have discussed that is C double bond C is in conjugation with C double bond. Here also one double bond is exists, that is double bond extended conjugation. Right here as double bond extended conjugation. Extended conjugation. Therefore, you have to add plus 30 nanometer. Again, one thing should be noted, that is interesting point, is that in the first benzene ring there are two double bonds. Like in the dienes, last we have discussed about, when two double bonds are in conjugation, this ring is called as a homoannular diene. It is called homoannular diene. You have to add, what is the value? That is plus 39 value. And last point is that is presence of exocyclic double bond. With respect to this second ring, how many double bonds exocyclic? This is first, only one, that is exocyclic. dB is equal to 1. With respect to second ring, that is equal to, you have to add it as 5 nanometer. Now what is the remaining? One by one we will see. First is for 6-member ring, we can write here as 215 for alpha position, 1 alkyl raised to 10. For delta position, you have to add 18. Okay. For extended, you have to add here 30. For homoannular, you have to add 39. And with respect to second, 1 exocyclic double bond. Now we can take the total. Lambda max is equal to, what is the? I can take the total 225 plus 18 plus 69 plus 5. Okay, 5 plus 5, 10, 10 plus 18, 18 plus 27. Okay, 4, 5 and 6, 1, 317. That is lambda max is equal to 317 nanometer. Okay, this is the most important example from the exam point of view. So you can call it as the star or PIMP. Now consider the last example. Likewise that example here. This is the C double bond O. You can call it as alpha, beta, gamma and delta. This example is similar to this example. Only the geometry is changed. One by one we can write it as first is as basic value for 6-member. For 6-member, what is the value? That is equal to 215 nanometer. Okay. For which are the alkyl substitutes here? First is alpha position and second is delta position. For alpha position, what is the increment? 10 increment. For delta position, what is the increment? 18 nanometer. Okay. Now again here homoannular diene. Therefore for homoannular we can write it as a addition of plus 39. Okay. Now this is the enone system. Got it? And this is the double bond extension here. Therefore you have to add here 30 nanometer. Okay. And last point we have discussed, that is here with respect to ring second, 1 exocyclic double bond, but here with respect to first ring, this is the exocyclic double bond. Therefore 1 exocyclic double bond with respect to ring first, therefore add it as 5 nanometer. You can take the total. Okay. There is no necessity of taking the total because all the data are the same of the above example. Just changing the geometry from upper side to lower side, the answer will be the same. We will check it as 215, 215, 10, 18, 39, 30 and 5. Therefore lambda max for this particular compound, that is equal to 317 nanometer. All of you understand these problems very well. I hope all of you understand. If you like, all of you understand these problems very well, you can like my video as a like, share and subscribe. Thank you.